Alright, so let's briefly recap here our process. We're dealing with functions that are composite functions. Okay, we have this function f that's a composite of the function u. And the question is, how do we handle that? We don't have a chain rule. Alright, so let's kind of work through our process here. We said that if you're getting the integral of this composite function, and you also have the derivative of that function in your integral, then you can integrate it as f of u du. Okay, so we looked at recognizing that inner function, the u, finding the derivative, and then expressing that in terms of du. Alright, and we had worked partway through an example, kind of using our basic process here. Recognize the function, the inner function, find the derivative, find that du, and get the rest of what's in the integral to equal that. Today we're going to look at ones where it's not already there. How do you work with it? We're not going to do super complex ones, but we are going to look at ones where you have to do a little bit of work to get it to be what it needs to be. Then, rewriting the integral as the integral of u du. Alright, so that's where we had gotten yesterday, and I think we had even integrated the integral of something square rooted is that something to the 3/2 divided by 3/2. Okay, so times 2/3. Now, here's where students tend to mess up this process. If they've gotten this far, one common mistake is to, with definite integrals, just go ahead and try to evaluate right here. Okay? However, we were integrating from 2 to 5, but that was when we're dealing with x's. That's x equals 2 and x equals 5. Alright, so you can't, at this point, plug in 5 and plug in 2, because you don't have any x's to plug in 4. So what you need to do at this point is substitute in, you're putting back the original u, in this case an x plus 3, then you can evaluate. Alright, so you'll see here, we put that x plus 3 back into our function, and now I can evaluate it at 5, and I can evaluate it at 2 and subtract, like my fundamental theorem of calculus says to do. Okay? Does everyone understand what we've done here? Okay, we had not quite finished this one yesterday. Alright, so then it's a matter of evaluating. Okay, we plug in the 5, we plug in the 2, and remember you subtract. We looked at the fundamental theorem of calculus a little bit ago, and then it's just a matter of using your calculator.
Could you show the formula again?
Yeah. Okay. Alright, so here's our f of u du, and the way we get that is by taking that derivative with respect to x, and then your dx's cancel out. Okay.
Can you explain how the du's and dx's work together and why we need to get them to go away?
Well, we need to get the dx's to go away so that we can integrate with respect to u. Alright? If you remember our basic notation, the integral of f of x dx, this is telling you what variable you're integrating with respect to. Alright? But if we have this derivative du dx in here, the dx's can cancel out, and you're left with du. So now we're integrating with respect to something different.
And du dx is the derivative of the inner function?
Yes. Yes. Okay. Now, we don't typically plug this part in. Usually what we will do, as we saw here, is we find du dx and then multiply by dx on both sides. And then we simply replace this whole thing with the du. Okay, so that's where that came from.
And in this one, du dx was
1.
okay because it was just x plus 3, so that's why we didn't add anything.
Yeah,
Okay.
yeah.
Can we do more examples of this
Yes,
kind?
yes, that's what I want to do quite a few of today. So let's take a look at this one, for example. Okay, this one's a little more complex. We have the integral of x squared plus 3x all to the 4th power times 2x plus 3. Now, my inner function, the inner function is this right here, okay? Calibration's a hair off. Alright, so that's u, okay? So right now, u equals x squared plus 3x, okay? Right now I have the integral of u times 2x plus 3 dx. And it's u to the 4th power. Okay? Does everyone follow that? Now, du dx is just the derivative of x squared plus 3x, so 2x plus 3. Okay? So, now I'm going to multiply both sides by dx, and I get my du to be 2x plus 3 times dx. Alright? So, I've identified my inner function. I've got something to the 4th power here. That something is the u. I use that to figure out what du is, and notice here, this whole thing right there is du. Okay? So now I'm taking the integral of u to the 4th du. Okay? Now what's the integral of u to the 4th?
U to the 5th over 5.
U to the 5th over 5. Okay?
Will they always work out like that? That derivative of one of our parentheses is the same as the other?
For us, it's going to at least be pretty close. Okay? In AP Calc or in college calculus, you're going to do ones that get a lot more complicated. For our purposes, they're going to be pretty nicely set up for you. Okay?
Why are we getting the integral of u5? Oh,
Yeah, now that we subbed in the du, we can take that, we can integrate that with respect to u, so u to the 5th over 5. Now though, we do need to plug back in what u was, okay? So we have x squared plus 3x over 5, okay, x squared plus 3x, sorry, to the 5th power over 5, and now that we're on the last step, we've got the plus c.
where did the du go?
The du is right here, okay? And when I integrate, it's gone, okay? Alright, so this right here would be our final answer. Yes?
So since there's no like interval or anything, there's nothing to plug back in, that's why, like the
Yes.
last one we got an actual number, and this one we get x something plus.
Yes. Yeah, here we're just finding the antiderivative. Okay. Back here, we were actually evaluating a definite integral. Okay. Which we'll deal more with definite integrals in our next section, but I like to throw those in occasionally here just to keep the fundamental theorem of calculus in our minds. So. All right, let's try a couple others. Here's three we'll do. Okay, and you'll notice they are here. They tell us what the inner function is. They tell us what that u is. Okay, so let's practice a little bit. That's u. What would du end up equaling? 3x
3x squared dx.
3x squared dx. Okay. So there's our du. So that's there. Those parts there make up our du. Okay. Du dx is 3x squared, so I multiply by dx, and du is 3x squared dx. So for part A then, really what we can integrate is simply the integral of, this is our u to the fourth, du. Okay, so pretty much just like the last one, something to the fourth is that to the fifth power over 5. Now that we've integrated, we substitute back in. So it's x cubed plus 1 to the fifth over 5 plus c. Okay?
So to find du, you find the derivative of u, and then you multiply by dx.
Yes. Yeah. Because remember, the derivative is du dx, but we only want the du. So. Okay?
But what if we get du that is not in the integral function?
It's not already there.
Yeah.
We're gonna look at a few like that after we're done with these couple. Okay? Because that's actually a question. I mean, these are really nicely set up, but in reality, they're not always going to be that way. So, how do we handle it? So, that's what we'll look at next. Okay? Alright, let's look at B though. Okay? We have the same u in this case. Notice our inner function is this exponent of e. Okay, it's e of u. Okay. So again, du is going to equal 3x squared dx. Alright, so here's one like the one that we were just talking about. Okay. I only have an x squared dx.
Oh, so we divide by 3.
Okay, so here's what we need. We need a 3 in here, right?
Oh, can you do like 3 integral that? It's the same thing.
We can do 3 on the inside as long as we counter it on the outside. So what would we put on the outside?
1/3.
A 1/3. Really, what I did here, I'll write it down here. I'm just multiplying by 1, right? I'm multiplying by a 3 over 3, but I'm putting the 3 on the inside, I'm putting the 1/3 on the outside. Okay? So we have 3x squared e to the x cubed plus 1 dx. And now I've got all of du. Okay? So now I can rewrite this as 1/3 integral. Here's e to the u power du. Okay? Now what's the integral of e to the u? E to the u. Alright? So that's 1/3 e to the u. And now I plug back in u. U was x cubed plus 1. So I have 1/3 e to the x cubed plus 1 plus c. Okay? Yes?
So the du is like in both of those, once you get to like the step where you plug everything back in,
Mhm.
that's, like, it's not an actual value, it's just like a notation thing?
Yes.
Okay.
Yeah. We had to do this so that we could integrate with respect to u instead of x.
Thank you.
Okay? Alright. Is this all making sense? Once you get the hang of it, it's okay, but it's kind of tough to to understand it first.
I kind of understand how to do it, but I just don't get the purpose of why do we have to do it this way.
Why do we have to do it this way? Partly, well, in this case, so with part A, if we wanted to find that integral without using u substitution, we would have to multiply out x cubed plus 1 to the 4th power. We'd have to expand that, and then distribute the 3x squared to everything, and then we could use the rules that we already know. Okay? But it's kind of like when we were dealing with the product rule with derivatives. You know, if we can avoid having to do lots of algebra, you know, using a rule like this, then it's worth it. You know? And then there are also some that are impossible to do without this. Okay, for example, this one here, without u substitution, the only way to find that integral would be to use the rectangles like we did in the very first section. You know, find the limit as the number of rectangles is approaching infinity, and that's even more of a pain than this is. So yeah, that's why we do it, just to kind of build our ability to integrate more and more functions. There are functions out there that there's really no good way to do it other than using the rectangles. But that's kind of our absolute last resort. So, yes?
Would we see that, like, the rectangles thing, like, on a test?
No.
Okay,
No.
or the IB exam, like, we don't
No,
really know how to do it.
No, AP will do that, in college you'll do that, but not for the IB. So. Alright, part C. Part C. Try, see if you can do part C on your own. Okay? We have sine to the 4th times cosine x dx. And they said make sine your inner function.
they increase the number of points on that. 4 isn't gonna do.
Can you still have X's or no?
Can you still have X's after you substitute in U?
Yeah.
Oh, I get what you're saying because of,
Because you still have like sine cube.
yeah, your du here would equal what? Cosine x dx.
Negative cosine X? No.
You're taking the derivative.
Oh yeah!
Yeah.
I was trying to figure this out. I'm so upset.
Remember, down is the derivative,
It's just too much.
up is the integral. Okay?
Oh,
So the derivative of sine is cosine, so cosine x dx. Yeah, this one's fun like that.
Since we just learned the whole multiplying by one thing, I thought, oh, we could do -1 on the inside, -1 on the
Yeah, that's
outside.
what I did.
And that would have been correct. So all right. So you recognize here that du is cosine x dx, right? We have the cosine x dx right here. So what do we get when we rewrite this? It's the integral of,
Oh, is it u to the fourth?
yes, u to the fourth du. Okay? So there shouldn't be x's still in here after you do your u substitution. Okay? So, as we've seen before, u to the fourth integrated as u to the fifth over 5. So, u is sine of x, so sine to the fifth of x over 5 plus c. And there you have it. Okay? Alright, so I think you're getting the basic process down alright. I'm gonna actually skip one of these because you guys are doing pretty well with that. Okay. Let's take a look at one of these. Okay. We have the integral of x squared over the square root of x cubed plus 5. This one's a little bit challenging to see what your inner function is. What would we have to make u in this case?
The square root.
X.
The square root of x cubed plus 5?
Or just
Because
x
it's
plus 5?
because it's squared dx, which makes it look easy.
Okay.
Negative.
And what did you say, Vicky?
Just x cubed plus 5?
Yeah, let's use just the x cubed plus 5. We'll deal with the square root in a second. But yeah, you've got the right part here. We're going to use x cubed plus 5. Alright, and you identified that x squared dx. Alright? If you look here, what's the derivative of x cubed plus 5?
3x squared.
3x squared, and then we've got the dx to make our du. Hannah, did you have a question?
Yeah, how did you tell that was you?
Well, basically, you kind of have to try to think in terms of the whole process, and this is why just practice is key with this. you might try some things and just realize, okay, that's not going to work. You know, if you tried doing, well, let's say you tried doing the whole square root. You know, the square root of x cubed plus 5, and then you tried to take the derivative of that. So you had 1/2 times x cubed plus 5 to the negative 1/2 times 3x squared. And you look at that and you look at the integral and you're like, okay, there's no way, you know, if I make that my u, there's no way I'm going to be able to get a du in there
Okay,
from
so
what I've got.
it's thinking ahead to see what you can match up to the original.
Yeah, basically. And that's where, if you did try this, then you might see, hey, wait, I see a 3x squared. Maybe I should just use the inside, okay? Because here's what we'll have then. Since this is a 3x squared dx, we have, let me write it this way first. I have a 1 over the square root of u, right? And then I've got this x squared dx part. Okay, I just pulled the x squared over here. I need a 3x squared dx. So what can I do?
1/3.
Yeah, I'm going to put a 1 over 3 out here, and I'm going to put a 3 right here. Okay? So now I have du. And I can actually integrate with respect to u. I'm going to write this as an exponent just to help us out. That's u to the negative 1/2 du. Now I can actually take the integral. Okay? Does everyone understand the process we've taken up to this point, though? Again, what Hannah asked is a great question. You know, how did we know to use x cubed plus 5? It's just practice. And sometimes you'll try one and you'll realize it just isn't going to work. So you just have to try something else. Okay, so, you know, in this case we have 1/3 times, it'd be u to the positive 1/2 divided by 1/2, so times 2. Okay, now we can substitute back in u. So it would be 2/3 x cubed plus 5 to the 1/2, or square root of x cubed plus 5. And then don't forget the plus c. Alright, so
We did the times 2 because of the a or 1 over a rule.
yes. Well, we did the times 2 because when you're raising u to the negative 1/2, sorry, when you're integrating that, you add 1, so it's positive 1/2, then you divide by the new exponent. So divided by 1/2 is times 2. Alright. Let's try one more. I'm gonna let you guys try this one.
white for now.
Do we just, we pick for the U, we pick the inside, so x squared minus x.
Okay, what did you guys pick for the U?
2x
to the third, 3x squared plus 1.
Yeah, that's the thing that's cubed. Part of it, and this is again just practicing with it. You notice how last time there was one part that was in the numerator, one part that was in the denominator in a radical. So when you see that other function being applied to something, that's probably going to be your u. Here we have this thing that's cubed, and then we have the other factor. Probably the thing that's cubed will be your u. And in this case it is, okay, because then,
No, I wrote down a 2 instead of a 3.
then when we take the derivative of that, you can kind of see, you can almost see this, right? So we're only missing a little bit, but we can handle that.
I just forgot to go. Yeah.
That's what we got. So I multiply by 6.
But like, okay, I already multiplied by 6.
When?
1/4 times over here. I multiplied.
Well,
yeah, I could have just done 1 6.
Okay.
Yeah, so,
Yeah.
So what do you
and you
know
get
six?
the 1/6 there.
What do you mean?
Yeah, that
You don't
was
even
good.
have the 6.
Yeah.
You
So
just need the 1/6 on the outside.
Oh, wait,
yeah,
wait.
that's the same.
Oh,
I see what you did.
yeah,
Yeah,
you
you
got
Oh.
by
that.
4 too.
That was the plus.
Yeah.
Well,
I ain't sure I'm right for this one.
oh,
You're what
the
here?
6 here was part of your
Out
du,
of what? 10?
so that shouldn't be there anymore.
I thought it was like
See,
67. but-
that's part of your du, it was x squared minus x. When you take out the 6, it's x squared minus x, so it matches.
We'll see.
Alright, so what do we have to put in here to get our actual du?
We get the multiply by 1/6 on the outside and 6 on the inside.
Yeah, we need a 6 there, so we're going to multiply by 1/6, okay? So that we have du right there, okay? Now, since we have that, now we can do our substitution. I really just have 1/6 times the integral. This is u to the third, and that is du. Okay? Notice the 6 that we put in here was part of the du, so it's not here anymore. Okay? So now I have 1/6 times u to the 4th over 4. Okay? Which, now I put u back in. 2x cubed minus 3x squared plus 1 to the 4th all over 24 plus c. Okay? Vicky?
Why do we just ignore du too?
Well, we don't ignore du. The fact is when we integrate, I mean, if you think about it, when we were integrating, you know, x squared dx, okay,
Oh, so it's
you don't keep the dx in your answer because you integrated that. Okay?
Makes sense.
So it's the same thing here with the du. You're integrating with respect to u, so that's kind of used up in the integration.
Use the bathroom.
Sorry,
Okay.
may I go follow up?
Yes. What we're going to do at this point, though, I want to give you guys the opportunity to just practice some of these. There's a number And this will help trying to find, okay, what should I use for U, what should I use for DU? Alright? And just work on trying to figure that out, okay? So I'm gonna let you guys work. You can work together, you can work at the board, okay, in small groups. Alright, but now's the time to really try to practice, ask questions, and
When is the test?
make sure we
on this
understand.
And everything?